Welcome! In this small example, let's find f of x. If f of 2 is given and it is 1, and the tangent line has a given slope at x, and it is a function, as you can see, because when we don't plug x equals some number, then it will not be a number, is the answer. So this is a slope at any possible input. Basically, you need to learn how to rewrite this problem using math. What we have here is, even though the slope is a function, what kind of function it is? Slope is a derivative, f prime. So we have given, let me change the color to blue, f prime at x is given as x minus 1 e to the x squared minus 2x. Then f at 2 is given, which is 1. Find f of x, right? So using the derivative, we will integrate the derivative to find the original function, plus c will show up, and we are going to use this initial value, it's called initial value problem, because initial value is given, to find c. Let's do it. F of x is the integral of x minus 1 e to the x squared minus 2x dx. How to do this integral? This should be done using u substitution. Let's choose everything in the exponent to be u. So I'll write down let u to be x squared minus 2x. Watch other my videos about u substitution if you want to practice more. Du then will be 2x minus 2 dx. And what I can see that 2x minus 2 is almost x minus 1 if I factor out or divide by 2. So let me factor out 2 over here. It will be x minus 1 dx. Now there are several methods we teach to perform your substitution. Let me explain you this method, which is faster. I need to find dx times x minus 1. Here it is, dx times x minus 1. So let me find that from the equation number 2. Equation number 1, equation number 2. Equation number 3 comes from the equation number 2. X minus 1 dx is, how to find that? Well, let's divide by 2. That will be du over 2. What is important? The first equation is important and the third equation is important. We'll plug these two into the integral. Let's see how it works. U comes up to the exponent. X minus 1 dx becomes du over 2. So the integral will be, I usually put this in the box like so. So visually you can see where is u substitution being used. This is u sub integral e to the u and then x minus 1 dx, as you can see from here, is du over 2. Du over 2. Kick out 1/2 outside of the integral. And now it's the easiest integral you can imagine. Integral of u du. Integral of u du. No, not u du. Integral of e to the u. Du is the easiest one because it's just e to the u plus c. Now remember, nobody knows what u is except you, right? So plug back your u. U is x squared minus 2x. So the integral will be 1/2 e to the x squared minus 2x plus c. Put this in the box. This is f of x. But we need to solve initial value problem. That means initial value was given. So step 1, we found general solution of f of x. But we need to find particular solution. Those are official terminology used for the initial value problems in differential equations. F of 2 is 1. Step 2, use the fact that at 2 the function should be 1 to find C. So I'm plugging 2, that's my input, into f of x. F at 2 is 1/2 e to the 2 squared minus 2 times 2 plus c, but that must be 1. Let me put in blue color. It must be 1. Solve for c. Solve for c. C is 1 minus 1/2 e to the 0, right? Because 4 minus 4 is 0. E to the 0 is not 0, remember that. C is 1 minus 1/2 because e to the 0